So let's talk a little bit about alpha. Alpha's the significance level, sort of that threshold of weird, as I've called it. It's also one other thing. It's the called type 1 error. So the process of hypothesis testing is not flawless. You can make mistakes, and these aren't human errors, like transposing a number or reading the z-table wrong. These are just mistakes that are built into the process and the logic of all of this. Mistakes that are built in. So think about, I've sort of made this very similar to like a trial by jury in the U.S. And at the end of the trial, what is the jury comes back and they either say that the person accused of the crime is guilty or not guilty. And sometimes they get it right, and then sometimes we find out later they got it wrong. One of the famous cases of people who spent time in jail when they were actually innocent. So these are the errors I'm talking about. There's lots of errors. We can let an innocent person go to jail, or we can let a guilty person go free. And those errors hopefully are made, not often, but they happen. Same thing with hypothesis testing. A type 1 error is rejecting the null hypothesis when it is true. Rejecting the null hypothesis when it's true. So what alpha is, again, alpha is still a probability, right? Over here I said alpha is a probability. Alpha is the probability of making a type 1 error. And not only is it sort of our threshold of weird, how weird does something need to be before we start sort of raising an eyebrow to it and start doubting the assumption of the truth of the null, it's also the likelihood that we make this mistake. So clearly people want to keep this small. Nobody likes to make an error. So when I say that there's a threshold of weird is at 5, I'm also saying I'm willing to live with a 5% chance that I commit a type 1 error. There's also another error. Just like I said, there were 2 errors. We call it type 2 error. Is retaining the null hypothesis. Everything seems to revolve around the null, right? That's it all, he gets to run the show, be a part of all of our concern. Retaining the null hypothesis, how would I finish that out? When it is what?
False.
Yes. And again, you've done nothing wrong. You've analyzed your data. You've done no kind of human error. It's just occasionally you can retain it when in fact, if we were God or some sort of deity, we could know whether or not it was really true or false. And this is called theta. And that's the probability of making a type 2 error. Clearly you want that one to be low as well, right? You don't want to make mistakes. You don't want to falsely discover something. So people are like, okay, well, I'm going to make type 1 error almost impossible to happen. I'm going to set it at 0.000001 or something. It was ridiculously small. The trouble is when you force one of these to be small, the other one's like pops up and becomes larger. So as you try to force one down and make type 1 almost impossible to happen because you're like, in this situation, a type 1 error would be terrible. Well, then guess what type 2 error does this? It starts to become more likely. Oh, and the flip side, if you make type 2 go away, type 1 becomes more probable. So it's sort of like you can't sort of force it too much. Now, again, an error of these types is, wrongly convicting someone of a crime or letting someone go free that's really guilty. So let's suppose that Michelle has a handbag addiction. She loves purses. And so she goes out and she robs an old lady who has a really nice handbag, okay? Snatches it from her. The weak and the unprotected, you snatch her purse. And so you go into a jury trial, and there's the evidence. We have some witnesses, and this one witness who's a little far-sighted or near-sighted, I forget which one's right, says they saw someone that sort of looked like Michelle snatch a purse from an old woman. And you're like, great. So the jury has to figure out, what they feel about this in order to, along with all the other stuff. But suppose if you had 10 people who witnessed someone who looked just like Michelle snatch a purse from an old lady, how comfortable would you feel about making a mistake and whether we're going to send her to, do some short time?
I wouldn't worry as much. You have 10 people that said they think it was her.
Yeah, so you have more. Basically, you have more evidence, right? You have more evidence in front of you. 10 people who can recount the same thing about her stealing a purse from an old woman. So the way you control these and keep them manageable is to have more evidence. And in our world, having more evidence means what?
Bigger sample size.
Bigger sample size, exactly. If you increase your sample size, if you can, sometimes it's hard because sometimes getting the data is expensive or time consuming, but if you can increase your sample size, the probability that you make these kind of mistakes, they both go down. That's the way we control them. Otherwise, if you try to force one down, the other one sticks up its nasty head and vice versa. So by having more evidence, that kind of makes sense if we liken it to a jury trial. We have more evidence against the person accused of a crime. We feel like we're going to make the right decision in the outcome of the trial. So these are with us. They we can't avoid them. We have to acknowledge they're there, and that's what our alpha is. It's a probability of sorts, so a threshold one, and also the likelihood we make a mistake.